2/3 of Earth's coastlines face an invisible threat. Saltwater is creeping inland through aquifers, driven by rising seas and climate change. Scientists built a global model, the G3MD, to simulate 440 years of groundwater chemistry. It reveals where salt intrusion will strike hardest. Hydraulic conductivity, how fast water moves through rock, determines everything. High conductivity means salt water penetrates deeper, faster, farther inland. Flat terrain is a liability. Where land slopes gently toward the sea, salt water can travel 9 kilometers inland by year 2300. Sea level rise is the primary engine. As oceans climb, the pressure gradient that usually keeps salt out reverses, inviting intrusion. The Mediterranean faces extreme risk. 1/3 of its coastal cities already struggle with salt water in their wells. By 2300, it worsens dramatically. South and East Asia house nearly 2.5 billion coastal residents. Their aquifers are among the most vulnerable to saline contamination globally. Southeast Asia will experience the highest absolute intrusion volume, 17.7 cubic kilometers of aquifer lost to salt by 2300. Central North America, East Australia, Central Australia, 85%, 83%, 77% of their coastlines will experience intrusion. Desert regions cannot afford to lose groundwater. The model assumes present-day populations, but coastal cities are growing. By 2060, 1.3 billion people will live within 100 kilometers of shore. Permafrost holds ancient carbon. As it thaws from warming, it releases methane and CO2. But carbon budgets ignore this committed emission source entirely. Glaciers worldwide shrink faster each year. Mountain water supplies vanish before eyes. But cryospheric monitoring networks depend on short-term project funding. The Arctic Ocean will experience its first nearly ice-free summer before 2030. That transformation reshapes global weather patterns for everyone on Earth. Political cycles run 5 years. Ice sheet collapse timescales run centuries. Governance structures cannot align with the physics they must respond to. Without dedicated funding for sustained monitoring and century-scale planning, adaptation becomes response to catastrophe rather than prevention. Time is the scarcest resource now.